talk about different models for the mean we could specify in terms of a regression. And let's come up with a working example. Let's say we're trying to predict or think about Wellesley students' GPAs. Perhaps at first we're just comparing two groups. Perhaps we're comparing GPAs among students who receive, I don't know, maybe a certain kind of advising versus students who don't receive that advising. And we have a bunch of data points. If I wanted to, I could make box plots instead of just drawing all the data points. Okay. Let's say that it's called GPA Y. Okay. So if I want to come up with a model for the mean of Y, given this advising variable, I could do it this way. What do we have here? Advising is an indicator variable, a dummy variable. Advising is equal to either 0 or 1. It's equal to 1 if the student had advising, and it's equal to 0 otherwise. Beta 0 and beta 1 are just symbols, they're just parameters, they're things that we can try to estimate. So how does this equation relate to that picture? The idea is that if you give me a particular student, and you tell me that she had no advising, then I will use this equation. I'll say, okay, well, the mean GPA, given that advising is equal to 0, because the student didn't have any advising, is equal to beta 0 plus beta 1 times 0. The student didn't have any advising. In other words, it's just equal to beta 1. In other words, I'm calling the mean of all the no advising GPAs beta 0. Sorry, this should be a beta 0, and this should be a beta 0. Let me just do it again. Let me delete these as well. Suppose we have a student who did not receive advising, and I want to use this equation to come up with a prediction for what her GPA will be. Looking just at this picture, what would you do? Looking at this picture, if you told me you had this new student with no advising and you wanted to estimate her GPA, wouldn't you just look at all the other students who have no advising and maybe predict the mean of all those students' GPAs would be this new student's GPA? Turns out that's what we're going to do with this equation as well. So if we have the mean of Y, given that this advising variable is equal to 0, because this particular student we're imagining did not have advising, following this equation we have beta 0 plus beta 1 times 0, because she did not receive advising. In other words, we have beta 0. Okay? So we're going to call the mean of the values, the GPAs for those who had no advising, we're going to call that beta 0. Okay? If we have another student who did receive advising, and you want to predict her GPA, wouldn't you just look at all the GPAs of the people who got advising and maybe take the mean of those GPAs as your prediction? Again, this model is doing the same thing. If I take the mean of Y, given that the advising indicator, the advising variable is equal to 1, I'm going to get beta 0 plus beta 1 times 1. In other words, I'll get beta 0 plus beta 1. In other words, the mean GPA among those who got advising is equal to beta 0 plus beta 1, which tells us that this vertical distance here is equal to beta 1. Beta 1 is the difference between the mean GPA among those who got advising and the mean GPA among those who did not get advising. If you don't have advising versus if you do, our prediction of your GPA changes by beta 1. So this is a regression equation, but all it's doing is coming up with other ways to express the means in each of these groups using these particular parameters. How would you estimate these quantities? You would estimate them in the most obvious way. If you want to estimate beta 0, I would do that using the mean of all the no advising students, right? That's what it should be. We're going to use a hat on the beta 0 to show that we're estimating it. So this is the true mean in the population of people who have no advising. We don't know what that is. Beta 0 hat is our estimate of that quantity. And we're going to estimate that using, I'll say, y bar no advising, the sample mean among those who got no advising. How are we going to estimate this quantity beta 1? This hat means we're estimating. That's going to be the difference between the mean GPA that we observe in our sample among those who got advising minus the mean GPA we observe in our sample among those who did not get advising. So if you can calculate these two quantities, the sample mean GPA among those who got advising and the sample mean GPA among those who got no advising, you can turn those into beta 0 and beta 1. Then you have your two estimates. And so now if someone comes along and says, hey, do you have an equation I can use to predict what GPA will be if I know whether somebody got advising? You can say, yes, plug in the 0 or 1 corresponding to whether that person got advising right here. And when you calculate the mean based on that equation, you will get your answer.